My name is Peter Hirst. I'm with New England Biochar. I've been to several of these conferences. Many, if not all of you, know me. We built the atom retort that Suzanne had her lovely picture taken with the sun going down and the tractor in the foreground. That was my partner, Bob Wells.
Is it okay that I borrowed the picture?
It's fine. It's Nesty's picture. You can steal anything you want from them. But we do make coarse char. We chop it up for most applications, but if you want it coarse, you can have it. You can have it coarse too. All right. Until Albert started speaking, I was just going to take you on a whirlwind tour of the Upper Klamath Basin and tell you what's going on up there, and tell you what the opportunities for biochar are in a region like this. Do I need this?
No, I do, and I was just decided not to be selfish.
But I had a better idea that I think is going to be more fun. So Albert has run you through the principles of biochar and some specific principles of community development around biochar. Jonathan has shown you. Can I have the lights on for a second? Thanks. Yeah, go ahead. I just switch them. I always think I'm far more important than anything up on the screen, but I actually do have some good pictures with this one today, so this is a decent compromise. But so instead of just a whirlwind tour and my telling you what's going on with biochar up there and with the community dynamics up there, we're going to do this like a law school exam, Albert. I'm just going to give you a set of facts and then follow it up with discuss. And I want us to have a discussion that may continue beyond here, but I want you to tell me what you see as the potential for biochar in these community dynamics. All right, this is all about the Upper Klamath Basin, which is the upper half of the Klamath River drainage and an incredibly vast and complex agricultural area. Anybody know where the pointer is? Okay. I may have to.
There you go. Yeah, you got it.
All right, it's going the wrong direction.
I could be your clicker and do the little arrows for you if you want.
All right, here's the whole Klamath Basin. Town of Klamath down here on the coast in Northern California. There's the geographical area of the U.S. we're in. Second longest river in California, even though that much of it is not in California. Second only to the Sacramento River. We're going to be focusing today on this area up here, which is the Upper Klamath Basin. You will also hear me talk about Lower Klamath Lake. Don't be confused. This is California, folks. Lower Klamath Lake is in the Upper Klamath Basin, okay? It's the Oregon and California. Lower Klamath Lake is right there. So we're going to be taking a tour from upstream to downstream, down here to Keno and the Keno Dam. And I'm going to describe the geographical and ecological and political area to you, tell you what's going on with some of the issues around water and nutrient management, the politics and the history of that, and a group that was formed a couple of years ago to discuss just the water piece of this. And then I hope that will lead to a discussion of opportunities for application and development of biochar. All right, here's the upper basin itself, and the important features here. The central feature here is Upper Klamath Lake. It's about 30 miles long, and this is the lake you supposedly see in a lot of advertisements for Klamath Lake blue-green algae. Has there anybody ever been persuaded to buy that stuff? Comes in little pills that cost about $3 a piece. That's all it's not really an algae, it's actually a bacterium from the Upper Klamath Lake. That's the centerpiece of the whole area here. Upper Klamath Lake is fed by the Williamson and Wood Rivers and another nice little creek called 7 Mile Creek, which you can just barely see sneaking up that way on this picture. That's Agency Lake up there, which for all intents and purposes is just the upper end of Klamath Lake. Important feature here, upper Klamath Lake is 30 feet long, 10 feet deep, and has a so-called blue-green algae.
Miles?
Yeah.
Miles.
30 feet, you said?
Yeah. What did I say?
We knew what you
Yeah,
thought.
30 miles long and 10 feet deep. It's not a deep, pristine alpine lake at all. It's essentially a big fertilizer factory because of this algae that lives there. Klamath Falls itself, which is really only about a 20-foot bench for a drop down into the city of Klamath Falls. Lake Ewanna, which is actually the upper stretch of the Klamath River. Then the Klamath River itself. Keno Dam is the lower end of our area concerned today. And then this area over here, Lower Klamath Lake, Tule Lake, and Clear Lake. We use the term Lower Klamath Lake advisedly. There's not much lake left, as you'll see. Well, but these are the features we're going to get familiar with in a minute. So, starting at the upper drainage, this is the headwaters of the Wood River. I'm not going to do all the rivers. I'm just going to try to give you a flavor for the overall dynamics of what's going on here. At the headwaters, the Wood River runs gin clear. You can sit at water level and see a quarter on the bottom of this river 50 feet away. Those light blue, the light blue coloring, that's white sand over there. And for those of you who ever tried to find a trout in a mountain stream, you should be impressed with the clarity of this water. Moving downstream a little bit, we're going to go to the 7 Mile Creek. As it comes out of the woods, you'll notice it's still a fairly pristine body of water. As it flows downstream toward Klamath Lake, it starts going through cattle country. Now imagine this pristine little stream with cows grazing right to the water's edge on every side. Between the headwaters of the Wood River and the lake, all of these streams pass through a population of 30,000 cattle and 4,000 or 5,000 people living in that area. So this is the first significant fact that should trigger your thinking about possible applications of biochar. All of these pastures are flood irrigated, which means you open a gate, the entire pasture, hundreds to thousands of acres, is flooded about 6 inches deep, left for a few days, and left to drain not only the water, but anything the water picked up while it was on the pasture with, hint, hint, 30,000 head of cattle. As we go downstream, we lose a little bit of elevation. There's some rapids, but basically it is a nice, slow, meandering flow through this 30,000 head of cattle. You may have seen this on your health food store shelf. This is the Klamath green, blue-green algae. Here is how it is usually advertised. Klamath Lake is typically misrepresented as Crater Lake. And they are absolutely shameless about it, because if they had to show you Klamath Lake, you would see this with the algae in it. Yes, that is a summertime algae bloom, Aphozomenon floss aquae, which is exactly what it sounds like. It's strings in the water. A close-up of Klamath Lake looks like that. And this looks like green noodle soup, folks. That picture is taken from about 10 feet away. And the bacteria is so dense it colonizes into little strings of noodles, and it's held together by a protein expressed by the individual cells of the floss aquae bacteria. And there's another little bug that feeds on the protein that holds those cells together, and that's what leads to the mycotoxin poisoning associated with floss aquae. The floss aquae itself is not poisonous, it's a little bug that feeds on it. Okay, hint number 2. So imagine a lake 30 feet long and 10 feet deep like this, ending at its lower reaches in the Link Dam. It's called the Link Dam because the river from here to the town of Klamath Falls links the upper Klamath Lake with the Klamath River itself. The Link River itself is about a mile long. Why they gave it a separate name, why they give Lake Uona a separate name before they call it the Klamath River, I can't answer that. But that's not the first strange cultural fact you will learn about this area. Okay, here's an aerial view of the Link Dam, those rocks in the upper right, upper left. Up there, that's what's left of the actual Klamath Falls. As you can see, it's just a granite bench and a drop of about 20 feet at the most behind the dam. But just putting in that dam was enough to back the lake up all the way up to Agency Lake, because the bottom of this lake is almost perfectly flat for 30 miles. So the entire level of that lake can be regulated from 4 feet deep in the summer to 10 or 12 feet deep in the rainy season, simply by this little dam right here. That's not a hydro project, that's just a retention dam. And here's a nicer picture, which I could say I took. Moving downstream from the Link River and the Link Dam, we come to Lake Uona and the town of Lower Klamath Falls itself. That tower is the remnants of one of the sawmills on the area. That's your nice scenic view of Lake Uona on a cloudy day, so you can't really see what a nice pea soupy green the water is. Moving downstream from moving downstream into, now this is the Klamath River proper, flowing through an area called Miller Island. Why it's called an island is beyond me. It's basically a big semi-wetland with cattle, again, as you can see in this picture, grazing with the egrets and herons right down to the water's edge. This stuff here, that's not a wind ripple. I'll show you a close-up of that. Most times of the year, when it's in warm weather, that's the floss aquae forming a nice coating on the top of the Klamath River just before it enters California over the Keno Dam. And this is not the worst picture. Those white spots in there, yes, they're dead fish. And this is not an unusual fish die-off, fish kill event. This is what it looks like normally in the summer. Now, I should say at this point, before it gets a little more complicated, exactly why all this is going on. Those nice pristine rivers you saw, they're full of naturally dissolved phosphate from some basalt formations up in the mountains up around Crater Lake. So let's think about what we've got so far. We've got phosphate-charged water flowing through 30,000 head of cattle and alfalfa fields, untreated, unfiltered, flowing through what used to be natural wetlands but is now pasture right down to water's edge, flowing into a lake that's 30 feet long, 30 miles long, and 10 feet deep. Oh, what I didn't tell you about the floss aquae, it's a nitrogen fixer. It takes all this phosphorus, chews it up, fixes nitrogen from the air, spits it all out, and its waste products and the dead bodies of the bacteria accumulate on the floor of this lake, still in the phototropic zone, so it continues to live to 3, 4, 5, 6 feet deep in the water. So all of these phosphates that are embodied in the bacteria itself are precipitated out when it dies, and of course there's a tremendous amount of dissolved material in the matter as well. So by the time this lake water is flowing over the Link Dam, it's basically like pouring Miracle Grow into the lower valley at the rate of about 1,200 cubic feet per second. And that's in the summer, that's in the dry season. In the rainy season, that 1,200 cubic feet a second goes up to about 3,000 cubic feet a second. All right, moving south from the city of Klamath Lake, along the highway, we pass 3 sawmills. I wasn't able to get a very good picture of the sawmill, so I've added a picture of a typical Oregon sawmill on the pond there, and you'll see right in the middle of it Exhibit 4, I guess we're up to now, of significant facts of what's going on here. Look at the piles of scrap, cutoffs, and chips and sawdust. This is a typical Oregon sawmill. This is not one of the ones at Klamath, but the ones I saw at Klamath, there was one about 3 times this size, and there was one just about this size inland off the pond. Okay, here's a repeat of that shot of Miller Island, very close to this. Here's another close-up. Send young children and sensitive people out of the room. That is the same material. That's the floss aquae bacteria. And if there were any doubts about what this does to fish, that's all of these white spots here are essentially fish kill. All right, now there's some good news. You remember that between Klamath Falls and the Keno Dam, there was this area off to the right, to the east on your radio dial of Lower Klamath Lake. This is Lower Klamath Lake. Looks beautiful, doesn't it? Well, the colors of this picture are terrific, but all that green, again, is all that miracle growth that's flowing over the Link Dam. About a third of it, about 800 cubic feet a second when I was there, was being diverted into Lower Klamath Lake, which is no longer really a lake. It's basically a series of irrigation channels and huge small grain fields, a lot of oats, wheat, and barley, which are also flood irrigated periodically, and they have industrial fertilizers added to them. Now there is some good news. To the east of Lower Klamath Lake is the Tule Lake National Wildlife Reserve. Much of the wildlife at Tule Lake is organic grain. I'm going to show you, these next 2 slides are 2 full section areas of oats, separated only by an irrigation canal. What you're looking here in the background is 600 acres of organic oats, to which absolutely nothing is added except periodic rotation with essentially natural wetlands. When they stop planting on this, they burn it, they open a floodgate, they move in 2 or 3 feet of water, and in 2 seasons it's been completely taken over by the native vegetation, tules, a lot of grasses, reeds, and thousands of ducks. Now this is not the commercial agriculture that's going on in the area. This is an experiment being conducted by Fish and Wildlife, and it's only on a very few square miles of this hundreds and hundreds of square miles area. So you now have the water going over Keno Dam, down what they call a channel, which is sometimes an open ditch, sometimes a pipe, into the Lower Klamath Lake irrigation district, being flooded onto the fields, growing more or less conventionally most of the small grains that are grown in the area. And when you're done with that water, it's got to go someplace. It goes to a place called the Klamath Straits Drain. And this is one of 2 channels that are this wide, which come floating out of this irrigation district with not only the floss aquae still in it, but a lot of macrophytes floating on top. I stood there at this pumping station for a half an hour and watched them unload probably 10 or 20 tons of macrophytes, essentially freshwater seaweed, off at the top of this channel, screened just in front of this pumping station, which then pumps it directly back into the Klamath River, all full of all of those nutrients, plus what it picked up in the Lower Klamath Lake, completely untreated, sent down to Keno Dam, and then sent on its way down the river to do its work with the salmon populations and the people that live the next 150 miles to the Pacific Ocean. Well, as you can imagine, there are some controversies around all of this, not the least of which is the fact that there are now 4 hydro dams owned by PacifiCorp between the lower end of our area of concern today and the end of what's considered the Upper Klamath Basin. There's 4 hydro dams totaling about 168 or 170 megawatts.
5 minutes.
You're kidding me.
If you want 10 minutes of discussion, you've got 5.
Okay, don't we go till 3? Okay, so in about 2000, the farmers in the area figured out that PacifiCorp was getting more water than they were entitled to run their hydro projects. They sued, and with no little input from the Bush administration, they won in 2001. They were awarded their full allocation of water rights, which is actually 120% of the water that actually flows into their areas. But when you're dealing with Western water rights, allocations and percentages are largely a fiction. So the farmers in 2001 won a legal victory. I'm going to skip ahead here and show you what one of the results of their victory was when the water was greatly reduced to the downstream flows without any reduction, by the way, of the total nutrients flowing. So now you have like super miracle grow flowing into the lower Klamath River. Can anybody guess what happens next?
Kill lots of fish.
There you go. This happened in 2002, and the tribes, as you can imagine, went nuts. Their cultural basis and their economic basis is lying on the beach in this picture. But the tribes are not without their power to persuade and communicate as well. Now, this particular demonstration, which just grabbed me, was about the Trinity River, which is a downstream tributary of the Klamath. But I think it says it all. Judge O'Neill is the guy that said that PacifiCorp could continue to have the water from the Trinity River as well, and not get to the fish or to this little girl's family. After this, in 2002, all hell broke loose in the upper Klamath. The farmers once again felt threatened that they might be losing their water rights. They marched in downtown Klamath. This was a demonstration that they held on, I think it was a 4th of July parade. You see the flag on the right. That's a bucket brigade that goes from Uona Lake to Upper Klamath Lake. There were enough people involved in this demonstration to hand buckets of water hand to hand from below the dam to over a mile away above the dam. This was a pretty powerful statement. I'm sorry about this next slide being sideways, but you get the idea. As the demonstrations and counter demonstrations went on among the tribes, the farmers, and the environmental interests, focus began to shift toward the owners of the dams, PacifiCorp. And PacifiCorp found it necessary to begin protecting its employees from physical harm by posting signs like this. Their people were under physical attack if they would appear in town with a PacifiCorp hat or label on the truck. The factions involved in this were serious. But as focus shifted toward PacifiCorp, it was realized that the dams were really causing all of this trouble. The water allocated to 168 megawatts, which for those of us that are trying to get energy from biochar, that seems like an awful lot of energy. 168 megawatts is nothing. The largest gas-fired power plant in California is 2,600 megawatts, and there are a bunch of those. Yeah, it's hydro, yeah, it's renewable, but look at the damage that 168 megawatts was causing to this community, not only to the river and the ecosystem, but to the community. The Upper Klamath Basin became a community separated by the resource of water. My hope is that it can be joined together by the combined resources of water, nutrient management, and biochar. If you have never seen this movie and you ever get a chance to, please do. This is a story of the protests and lawsuits and eventual resolution of the lawsuits in what's known as the Klamath Hydro Settlement and the Upper Klamath Restoration Project, from the point of view of a Yurok Indian man who found himself on the streets of San Francisco and felt moved to move back with his tribe, renew his contacts with his tribe, just about the time all this was happening. So his reintroduction to his people in the Upper Klamath region was part and parcel to this story of the resolution of all these factions. It's quite a moving story. Long story short, everybody figured out that Pacific Corp was the bad guy. You remove the dams, get rid of the excess drain on the water, and everybody has more or less enough water to continue to grow the crops, feed the salmon, and everybody is more or less happy. This is a 600-page document that took 2 years to hammer out. It still depends on a finding of the Secretary of the Interior and an act of Congress to put it into place, but at least people have come to an agreement in principle. I got into this because I was asked to introduce biochar at a workshop that introduced the water piece of this. This workshop identified three basic technologies for treating the water problem, to which I added biochar as part of the workshop. And your mission, should you choose to accept it, is to think through all of the ecological and social and economic elements that I've just taken you on a whirlwind tour, and imagine how biochar can fit into this. Oh, did I also mention that when those dams are removed, 168 megawatts of hydropower has to be replaced by renewable energy? Guess what I'm thinking. So, the primary technologies that were identified for remediating the water, remediating the nutrient situation in Upper Klamath Lake are restoration wetlands. There's a diagram and there's an example. I'm sorry, that's a treatment wetland. The next is a restoration wetland. There's a diagram of how it works. Note the label in bold in the upper left. This is what they're looking for as part of this, as part of the restoration wetland treatment. There's an example of the restoration woodland installed by the Nature Conservancy at the Wood River Delta. Here's an example of a wetland restored by the Nature Conservancy at the Williamson Delta. Here's another view of Wood River. The third major technology that's been identified is land-sited filtration plants. Remember, there's 2 pinch points involved in this system of nutrient flow. One at the Link Dam and another one at the Klamath Straits Drain Pumping Station, each one of which are doing about 2,000 cubic feet per second of water. Here's a barge that harvests the so-called blue-green algae from the lake. This is a multi-layer filtration system. Guess what I'm thinking about adding to this filtration system? And here's a dredge. This is the fourth major technology that's been identified for remediation in this area. Simply removal of the bottom layer of the lake, which contains all of this precipitated phosphate. So what you see being pumped from Basin A into Basin B here is a sedimentary layer of about 3 feet thick. It's almost as deep as the water in the lake, 30 miles long. Guess what I'm thinking might be done with all this nutrient-rich silt. A couple other resources that have looked at similar treatments around the country, specifically with respect to the Chesapeake Bay. All right, just in case you haven't seen enough graphs over the last 3 days, this is the last one. The bottom line of this is that one study at least found that biochar is by orders of magnitude, hundreds and hundreds of %, the cheapest way to fix, remediate, and recover nitrogen. And here is the, I'm going to take my time to read this out loud. This will be the last thing I say. This was my major accomplishment of having participated in this session. I negotiated the following language with EPA Region 9. The United States Environmental Protection Agency, Pacific Southwest region, is exploring the potential for biochar to improve surface and groundwater quality. US EPA also promotes the effective reuse of waste materials and practices that help mitigate the impacts of climate change. Our review of the literature indicates biochar is especially well suited for nutrient removal from water and in improving soil structure and fertility that could result in reduced sediment loading of surface waters. Research has also demonstrated biochar's carbon sequestration capacity and its cost effectiveness when a feedstock that is considered a waste product of an industrial process is available near biochar production facilities. As most biochar research has been conducted at laboratory or bench scale, large scale field applications of biochar practices and technologies are needed to demonstrate the ability of biochar to prevent nutrients and sediments from entering the surface and or groundwater. Eric Bias, Sustainable Infrastructure Office of EPA 9, and I'm going to close with my thanks to Doug Clayton for my favorite biochar picture of all time. Thank you.